Hello. In the last class, we discussed about some operations on dependent variable. In this class, let us continue our discussions on operations on dependent variable. So let us continue our discussions on operations of uh, on dependent variable. Uh, the next operation is multiplication. So, for example, if x1 of t is the input signal and x2 of t is another input signal, then the output y of t y of t is multiplication of the signals x1 of t and x2 of t. So at every instant of time t, the signal values of x1 and x2 get multiplied. For a discrete case, if x1 of n and x2 of n are the input signals, then y of n is x1 of n multiplied by x2 of n. So we will take examples. Let us assume that we have a sinusoidal signal extending from minus infinity to plus infinity. So let me consider this as x1 of t. And I have another signal which is 0 for all the negative values of t and whose value is 1 for all the positive values of t. This signal is actually called as a unit step function, which we'll discuss in this course later. So when I multiply these two signals, x1 of t and x2 of t, as you can observe, for all the negative values of time t, since x2 of t is 0 here, 0 into anything is 0, so the output signal will be 0 here, and positive value of the signal is multiplied with plus 1, so I'll get a signal of this nature. This will be y of t. This is how you can perform multiplication of two signals. We can also consider an example of a discrete case. Say n is equal to 0, the magnitude is 1, n is equal to 1, the magnitude is 2, n is equal to 2, the magnitude is 1. This is one signal, say x1 of n. And x2 of n, let us assume that this is 0 and this is 2 and this is, say, minus 1. So 0, 1, 2, this value is minus 1. This is x2 of n. When I multiply these two signals now, at 0, one of the value is 0, so 0 into anything is 0. At 1, 1 is 2, the other value is 2, so 2 into 2 is 4. At 2, 1 is having a value equal to 1 and the next one is minus 1, so 1 into minus 1 is minus 1. So this will be the output signal YFN. This is how we can perform multiplication of two signals. We will now consider one more operation on dependent variable, that is differentiation. Now this operation is only defined for continuous time signals because you cannot differentiate discrete time signal. So as the name itself says, if x of t is the input, y of t will be dx of t by dt. That means it is differential of the input signal x of t. So an example that I can give is an inductor. So if L is the value of the inductance and V of t is the voltage applied across the inductor, I of t is the current that flows through the inductor, then you know the voltage across the inductor V of t is given by L into di of t by dt. So this is how differentiation operation can be performed. We will also consider the next operation being the integration. So if y of x of t is the input, then the output y of t for an integrator will be integral of the input signal. So x of tau d tau, where tau is a dummy variable here. So good example of integration is a capacitor. Suppose if C is the value of the capacitance and V of t is the voltage across the capacitance, I of t is the current through the capacitor. So we know that the current I is dq by dt, rate of change of charge, which is equal to d into q is C into V divided by dt. C is a constant, so it is C into dV by dt. This is how I can write the current equation. Now if I want the voltage, I have to integrate on both sides. So the voltage V of t will be 1 by C integral minus infinity to t I of tau d tau. So this is how integration operation can be performed. And both integration and differentiation operations are defined only for continuous time signals. Let us now consider an example of differentiation. If the given signal x of t is 5 minus t or t between 4 and 5, it is equal to 1 for t between minus 4 and plus 4. It is equal to t plus 5 for t between minus 5 and minus 4, and it is equal to 0 otherwise. This is a signal for each value of t defined at different instants of time t. Now the question is, first plot x of t, then find y of t equal to dx of t by dt. So first let us plot this signal. As you can see, the signal is there from minus 5 to plus 5. So let me just show. This is t, x of t. This is minus 5, so minus 4, plus 4, plus 5. This is 0. So what you notice here is from minus 5 to minus 4, the signal is t plus 5. This is equation for a straight line with slope is equal to 1. So this will be the signal. From -4 to +4, the signal is equal to +1. And from 4 to 5, you can observe that this is again equation for a straight line with the slope equal to -1. So this is the signal, which is a trapezoidal signal. Now if I differentiate this signal, so what you notice here is from -5 to -4, the signal is a straight line with slope equal to 1. So you know that, let me write it here. So the equation for the signal here is t plus 5. So when I differentiate this with respect to t, I'll get 1 and the differential of the constant is 0. So I'll get a constant as 1. Therefore, from -5 to -4, the signal looks like this. The magnitude is equal to 1. And from -4 to +4, the value here is 1. Differential of a constant is 0. So I'll get it as 0. Again, from 4 to 5, the signal here, it is minus t plus 5. So if you differentiate it, I'll get -1. So the value is -1. So you get two pulses, one between -5 to -4 and another between 4 to 5. And all other values here are 0 because differential of a constant is 0. So this is how the differentiated output looks. Okay. So this is how I can perform integration and differentiation on the given signal, and this actually completes the operations on dependent variable. In the next class, we will discuss some operations on independent variable, that is the time axis. Thank you.